Welcome to Chem Time.
Hello viewers, welcome to the YouTube video presentation. From today onwards, we are going to start a new subject, that is material and energy balances, and this subject is also called as process calculations. And this subject is useful to chemical engineering, petrochemical engineering and pharmaceutical engineering students. My experience with industry suggests after completing BTech, when an engineer joins as a process engineer in a chemical industry, the first thing he will be asked to do is the material balances and subsequently energy balances. But there is a difference between the plant experience and the experience you gain when you learn this subject. When you learn this subject, you will be calculating the amount of raw material to be used to produce a given amount of product, or what would be the amount of product formed from a given amount of raw material. When you apply this subject in a chemical industry, the data on the quantity of raw material is available, the data on the product is also available, and you will be asked to identify the losses. And sometimes you may have to carry out material balances separately, and sometimes you may have to carry out material and energy balances together. And energy balances deal with whether the reaction generates energy or need energy, or what would be the exhaust gases temperature when reactions involving combustion are conducted, and how effectively the energy can be utilized so as to optimize the use of power. Engineers deal with the following components. One is solid dissolved in a liquid to form a solution, liquids or gases. The word stoichiometry, which is repeatedly used in process calculations, refers to the mathematics of chemistry. Wherever you attach numbers to chemicals, it becomes stoichiometry. And the first concept in stoichiometry is mole, and mole is defined as mass by molar mass. Some people use the word molecular weight in place of molar mass also, and molar mass is calculated as sum of atomic masses of elements present, and atomic masses are expressed with reference to isotope of C12 atom. I'm taking an example to calculate the molar mass. The molar mass of potassium chlorate is to be calculated. First, you write the chemical formula of potassium chlorate, that is KClO3. Identify the number of atoms of each element. In this particular potassium chlorate, there is one potassium atom, one chlorine atom, and three oxygen atoms. List out the atomic mass of all the three elements. Potash is 39, Cl is 35.5, and oxygen is 16. Therefore, molar mass of potassium chlorate is calculated as atomic mass of potassium into number of atoms of potassium plus atomic mass of chlorine into number of atoms of chlorine plus atomic mass of oxygen into number of atoms of oxygen, that gives rise to 122.5 grams per mole. Remember, units of molar mass are grams per mole. Equivalent weight can be calculated from the knowledge of molar mass as equivalent weight is equal to molar mass by n factor. And this n factor is calculated as total cationic charge or total anionic charge. For example, if you take potassium hydroxide, it got one potassium ion and one hydroxide ion. So the n factor will be 1. If you take calcium hydroxide, it has got the charge on calcium as 2. So the n factor will be. Now, there are different means to express the concentrations of solutions, and solution will have two components. One is the solute, the other one is the solvent. Solute is present in lesser quantity than solvent, and the solute is dissolved in a solvent to form a solution. The extent of dissolution of a solute in a solvent depends on the solubility of a solvent. difference between saturated, unsaturated, and supersaturated solution. A solution is said to be unsaturated if it dissolves less solute than maximum possible solute, and the solubility depends on temperature. A solution is said to be saturated if it dissolves maximum possible solute. A solution is said to be supersaturated if it dissolves more than maximum possible solute. Difference between solubility and miscibility. Solubility refers to the amount of solute that is soluble in a solvent, and there is a limit to this solubility. Whereas in case of miscibility, solubility at all proportions. For example, if you take ethanol and water, you say ethanol and water are miscible, you never say ethanol and water are soluble, because at all proportions of ethanol and water, they dissolve. Now, other means of expressing the concentration are molarity, and molarity is defined as moles of solute per liter of solution, and normality is defined as number of equivalents per liter of solution, and equivalents are obtained by molar mass by n factor, and molality of the solute is defined as moles of solute per kg solvent. With this, I conclude my video presentation. Thank you.
Request you to like, share, and subscribe my channel.